I recently got these messages with a very good question that I wanted to answer here. Why is abstract algebra interesting? And this is coming from a student who found real analysis fun and sort of motivated as trying to formalize the concepts of limit and continuity, but who found abstract algebra as learning random facts rather than building towards something. And they are asking me, what is the big picture? What is abstract algebra building to? And I can totally see that point, because if you get a course in abstract algebra where the instructor is not motivating the topics, then you're just going to see a laundry list of topics. You're going to learn what's a group, what's a ring, what are polynomial rings, what's a module, what's a vector space, what's a field, what's Galois theory, etc. And the answer to why abstract algebra, why is it interesting, it's because, well, it's so huge. There are so many aspects of abstract algebra that appear in so many other places that our algebra courses have to cover a lot of ground, because we don't know where the student will see abstract algebra in a later life. But as an instructor, when I teach abstract algebra, as much as I want to cover a lot of ground so you see a lot of material that might be useful later in algebra and in other places, in analysis, probability, and so on, I want you to have some goal in mind of something we're trying to solve, and something that is really cool. For example, you might want to learn group theory because you want to understand the Rubik's Cube and the mathematics behind the Rubik's Cube and the mathematics behind the transformations of the Rubik's Cube that explain how to solve it. You might want to motivate abstract algebra and, for example, field theory as the study of trying to understand the insolvability of the quintic equation, the solvability of other equations of the first, second, third, fourth degree, and why the quintic equations cannot be solved by radicals in general. If you want a real goal of abstract algebra, it might be the fundamental theorem of algebra, which is the construction of the complex numbers, as the pinnacle of what algebra was set out to be from the beginning, which was how to find solutions to algebraic equations. And the complex numbers are that field where all equations have a solution, all algebraic equations have a solution, and the fundamental theorem of algebra tells you exactly that over the complex numbers, any polynomial equation of any degree has a solution in the complex numbers. Or you might want to have in mind problems from other areas. For example, in number theory, to understand the solution of Fermat's last theorem, you need to learn a lot of algebra.